This is lesson 3-1B. So please open up your notebook to the next blank page and write 3-1B homework on the top of your page. In this lesson, we're going to be evaluating exponents when a fraction is the base, and then we're also going to be looking at exponents with a base of 10. So let's start by looking at this try it question. Let's rewrite that in our notebooks. And it says evaluate 1/3 to the third power. And that 1/3 is in parentheses because they want you to know that the 1/3 is the base. They don't want you to be confused and think that it's numerator 1 to the third power and then the denominator is just 3. So that's why they have that fraction written inside parentheses with our exponent. That way there's no confusion about what the base will be. The base will be 1/3. So how do we represent 1/3 to the third power? So we look to see what our base is. Our base is whatever is that larger number, whichever has the exponent. So our base is 1/3. That means we're going to be repeating or using 1/3, multiplying it times itself. 1/3 times 1/3. Well, how many times am I going to multiply 1/3 times itself? I look at the exponent to help me. The exponent is 3. That tells me that I'm going to multiply 1/3 times itself 3 times. 1/3 times 1/3 times 1/3. So now let's think about what this means. 1/3 times 1/3 times 1/3. Well, if we just had 1/3 times 1/3, when we multiply fractions, we multiply the numerator straight across. 1 times 1 is 1. Denominator times denominator, 3 times 3 is 9. So 1/3 times 1/3 would be 1/9. Okay, so that took care of this. 1/3 times 1/3 is 1/9. Well, now let's bring down that next times 1/3. Again, we multiply the numerators. 1 times 1 is 1. Multiply the denominators. 9 times 3 is 27. And so our answer would be 1/27. So 1/3 to the third power is 1/27. Now we have calculators. So let's look at how a calculator would be able to help us to solve this problem. So I'm going to rewrite this. 1/3 times 1/3 times 1/3. So now our base here is 1/3. Can I just put 1/3 into the calculator? Is there any way for us to do that? 1/3, put it in a calculator. No, there's not. And this is where it's important that we remember those rules, that when we multiply fractions, you have to multiply the numerators. So we can multiply the numerator straight across. Well, 1 times 1 is 1 times 1 again is 1. That's how my answer is 1 on top. Well, now I can multiply my denominators. 3 times 3 times 3. Okay, I can put that into my calculator. 3 times 3 is 9. 9 times 3 is 27. So we can use our calculators to help us with this, with these exponents, but only if we remember those basic rules for multiplying fractions, because you can't put 1/3 into your calculator. You have to break it up and multiply the numerator straight across, multiply the denominator straight across, like you would do if you didn't have a calculator. Okay, so now let's look at example 3. Example 3 says that we're going to evaluate expressions with exponents. Julia calculated the FOIL as 1 9/10 times 10 to the 5th power units thick. Thumb calculated the FOIL as 183,000 units thick. Which calculation represents the greater thickness for the FOIL? So they give us a hint here. We have to evaluate the expression 1 9/10 times 10 to the 5th power. Okay, so 10 to the 5th power, well, we'd have to figure out what that is, but we're also going to look for patterns here to help us. So let's look at this chart that they have. 10 to the 1st power, well, any number to the 1st power is that number, 10. 10 to the 2nd power, 10 to the 2nd power is 100. 10 times 10, 10 to the 2nd power is 100. You don't have to write this. 10 to the 3rd power, well, 10 times 10 is 100, times another 10 is 1,000. 10 to the 4th power is going to be 10,000. Do you notice a pattern? And then 10 to the 5th power is 100,000. And I can put the commas in here. Do you notice a pattern? Maybe we're looking at what the exponent is and the number of zeros. So when we're multiplying with a base of 10, whatever the exponent is, that tells you how many zeros you're going to have. So 10 to the 3rd power, 3 zeros, 1,000. 10 to the 4th power, 4 zeros, 10,000. 10 to the 5th power, 5 zeros, 100,000. So that's a little shortcut to help us remember those base 10s. Now, we have to use that information to help us understand what 10 to the 9th power times, we have 1 and 9/10 times 10 to the 5th power. Well, we said that 10 to the 5th power is going to be the number 1 and then 5 zeros written after it. So that means 1.9 times 100,000. Well, anytime we're multiplying something with zeros, that means we can just move the decimal point. So we have 5 place values with zeros in it, which matches that exponent of 5. So that means that if I am multiplying a number times a base 10 exponent, I will just move my decimal to the right because I'm multiplying the same number of spots as the exponent. So 1, 2, 3, 4, 5. So the reason we did that, that's a little shortcut. We take the 10 to the 5th power. We talked about how 10 to the 5th power means that we're multiplying it times 100,000. 100,000 has 5 zeros. So we move the decimal point 5 zeros, which matches that same number that was in the exponent. So my answer here would be 190,000. So now let's go back to the question. It's pretty much saying who's right. Tom calculated the foil as 183,000 units thick. Which calculation represents the greater thickness for the foil? So is 190,000 bigger? Or is 183,000 bigger? 190,000 is bigger. Okay, so let's just do a few practice questions. Let's try number 10. 1/6 to the 2nd power. So we have our base as 1/6, our exponent as 2. So what is 1/6 to the 2nd power? Make sure you're writing it in your notebook, please. 1/6 to the 2nd power means that we would have 1/6 times 1/6. Well, I can't put 1/6 in my calculator, so that means I have to separate this. I'm going to start by doing numerator times numerator, top times top. 1 times 1 is 1. Now I can do the denominator, 6 times 6. 6 times 6 is 36. So my answer, what is 1/6 squared, or 1/6 to the 2nd power? 1/36. And the last question I want us to look at is number 14. So rewrite it in your notebook, 4 and 5/10 times 10 to the fourth power. So you look at the exponent attached to the 10, and that tells you how many times you're going to move the decimal point. So how many times are you going to move the decimal point in 4.5? Well, I look at my 4. The 4 in my exponent, the 4 tells us we're going to move that decimal 4 times to the right. So let's move it. 4 and 5/10 times 4 to the 4 and 5/10 times 10 to the fourth power means I'll move my decimal 4 times. Fill in all those blanks with zeros. My answer is 45,000. And just as a quick reminder, the reason we can do that, well, 4 and 5/10 times 10 to the fourth power, we're really just saying 4 and 5/10 times 1,000. Well, I'll move my decimal point, times 10,000, because we have an exponent of 4, so we should have 4 zeros. That means we'll move our decimal point 4 times. 1, 2, 3, 4.